Now come to another topic. Now, in a triangle ABC, we consider the angle B. There will be two angular bisectors of angle B. One will be acute angle bisector, other will be obtuse angle bisector. So, for any angle formed out of meeting of two straight lines at a particular point, there will be two bisectors like this. Suppose this is one line and this is other line. They meet at point P. Definitely this is PM and this is PN. Equation of PM is taken to be, and equation of Pn is a2x plus b2y plus c2 बराबर 0. Now the angular bisectors of the angle NPM will be given by this formula. Angular bisectors of the angle NPM will be given by like this: a1x plus b1y plus c1 divided by a1 square plus b1 square is equal to plus minus a2x plus b2y plus c2 by a2 square plus b2 square. One will represent the acute angle bisector and the other equation will denote towards obtuse angle bisector. Now, which equation will be of acute angle bisector and which one will be the equation of the obtuse angle bisector? It will be very clear from the question which we discuss. The question is, lines whose equations are for x plus 3y minus 6 and 5x plus 12y plus 9 बराबर 0. Find the equation of acute angle bisector. Second part is the equation of obtuse angle bisector. Third part is the equation of bisector containing the origin. For this, first we determine the bisectors of the equation, bisector of the lines whose equations are given to be so and so. The angular bisectors of the given lines will be given by the equations four x plus 3y plus 6 divided by 4a square plus 3a square under root is equal to plus minus 5x plus 12y plus 9 divided by 5a square plus 12a square. On further simplification, we get 4x plus 3y plus 6 divided by 5 is equal to plus minus 5x plus 3y plus 12y plus 9 divided by 13. On due simplification, we get two bisectors as 9x minus 7y minus 41 is equal to 0 and 7x plus 9y minus 3 equal to 0. Now, one of these equations will be the acute angle bisector and the other will be the obtuse angle bisector. Now, the question is to determine which one is of obtuse and which one is of the acute angle. For this, we take any of the bisectors and determine the angle between one of the bisectors and the one of the given lines. If it is found to be obtuse, then the bisector under consideration will be the obtuse angle bisector, and in this case definitely the other bisector will be the acute angle bisector. For this, we calculate the angle between the bisector. We determine the angle theta between the bisector 9x minus 7y minus 41 is equal to 0 and the line four x plus 3y minus 6 is equal to 0. We can determine it by the formula of angle between two straight lines whose slopes are known. We calculate the angle like this: tan theta is equal to mod of m1 minus m2 9 by 7 minus 4 by 3, that will be plus by 4 by 3 by 1 plus m1 into m2, that comes out to be 1 plus 9 by 7 multiplied by minus 4 by 3. We solve it as 9 into 3, 27, 7 into 4, 28, 55 by 21 divided by 21 minus 36, that will be equal to minus of 15 divided by 21, absolute value, we get 55 by 15, which comes out to be 11 by 3. Which is definitely greater than 1. So the angle between the bisector 9x minus 7y minus 41 is equal to 0 and the line 4x plus 3y minus 6 is equal to 0 is definitely not an acute angle, because the angle is greater than 45. So the equation 9x minus 7y minus 41 is equal to 0 will be nothing but the equation of the obtuse angle bisector. So 9x minus 7y minus 41 is equal to 0 will be the obtuse angle bisector, will be the obtuse angle bisector. So the other bisector will be the acute angle bisector, like this. The other bisector is 7x plus 9y minus 3. So 7x plus 9y minus 3 equals 0 will be the acute angle bisector. Now the third part is the equation of the bisector containing the origin. For this we have to calculate the equation of bisector once again, but there is a specific method for it. We change the constant into a positive term. This is already a positive constant, and this negative constant can be determined by multiplying minus in the entire equation. The two constants will be positive, and then we determine the equation of angular bisector by considering the plus sign only. The equation coming out of that will contain the origin like this. First we make both the constant positive. Here one constant is already positive and the other is negative.